Event sourcing architecture. Let's understand what is this architecture. Event sourcing architecture is an architectural pattern that stores the state of an application as a sequence of events. Event sourcing, so sequence of events, rather than as a current state. Each event represents a change or action that has occurred in the system, allowing for a complete historical record of all changes. Let's understand this architecture with one use case. Order management is the use case. Let's consider an order management system for an e-commerce platform where customers can place, update and cancel their orders. Here is how the event sourcing architecture can be structured and utilized in this scenario. And we are also going to discuss in this scenario only, we are also going to cover the key components of this architecture. So first one is the command layer, where we will have the commands as well as the handlers, actions that change the state of the application. Below can be the actions: place order command, cancel order command, ship order command. And the handler would be basically what is the business logic written to handle each of those commands. These can be the handlers, right? So this is one layer. Then event store. Events would be order placed, order cancelled, order shipped, right? And stored in a database designed for high write loads. Like, I mean, these are the examples. There are multiple databases. Cassandra is one of that database for event store. We can use that. After event read model, basically projects denormalized representation of data based on events. So for example, current orders for a user or order history are typically stored in some database. It can be relational or NoSQL database. We will have event bus and we will have user interface, whether it's a web application or mobile application. Let's understand this whole order management with the workflow. What are the steps of doneness will happen. So user action, a customer places an order by submitting a place order command after filling their cart. Then command handling will happen. The handler validates inventory and payment, then creates an order placed event with order details. Storing the events, the order placed event is saved in the event store. Event publishing, the event is published via the event bus. Event handling, we will have projection service and we have notification service. So the projection service update the read model with the new order, and notification service sends an email confirmation to the customer, right? And then user queries, the user query the read model to view their orders. Handling changes, if the customer cancels, a cancel order command is issued, processed and order cancelled event is published. Reconstruction of state, the system can replay stored events to reconstruct their order history if needed. So we see that how this architecture style is placed for this use case. Let's see the key characteristics of this architecture. So we know now event storage. Instead of storing just the current state of an object, all changes are captured as events and stored in an event store. This provides a comprehensive history of all actions taken. We have already seen that order placed, order cancelled, right? Immutable events. Once an event is stored, it is immutable, meaning it cannot be changed or deleted. This ensures a reliable audit trail of changes. So every time an event is happening, it is added to the book. We are not overriding it because it is immutable. State reconstruction. The current state of an application can be reconstructed by replaying the sequence of stored events. This allows for various representations of the state at any point in time. And separation of concerns, of course. Business logic is often separated from the data storage logic, allowing for cleaner code and easier maintenance. And of course, it's event-driven communication, right? Event sourcing often works well with event-driven architecture, where different components communicate through events, enabling loose coupling. So I am always saying that whenever we actually work for any project or opportunity, we combine different flavors of architecture, and then it is always a tailored architecture. Let's see the benefits of this architecture. Auditability perspective, yes, the complete history of changes provides a robust audit trail, making it easy to track what happened and when. Flexibility, systems can evolve over time. New features can be added by processing existing events without altering the stored data. Debugging and testing, historical events make it easier to reproduce scenarios for debugging and testing. So for example, some issue came while the order is placed. Now we know with the audit trail that these are the events had happened earlier. We can replicate the same issue again with the same type of steps. Decoupled architecture, components can be developed and deployed independently, responding to events as they occur. Let's see the use cases of this architecture. Very important, financial application, because we need to keep all those records in the book. Financial applications, event sourcing is commonly used in banking and finance system when a complete history of transactions is critical. E-commerce system, in e-commerce platforms, capturing user actions as events help track orders, states and changes effectively. Collaborative applications, applications that require tracking changes made by multiple users, document editors, right, can benefit from event sourcing. Yeah, whenever we want to track those events, the sequence of those events, right, we should consider this architecture. Event sourcing architecture is a powerful approach for applications that require a detailed history of changes and enhanced flexibility in managing state, making it suitable for various domains where tracking and auditing are essential.